Welcome back to Daily AI News at Let's Data Science. It's 2026-0402. Today, we're diving into some pivotal developments from the future of machine intelligence to major product launches. Let's get to it. We begin with a fundamental rethink of how we build intelligent systems. Researchers at UCLA Health have published a peer-reviewed paper in the journal Neuron, arguing that today's multimodal large language models are missing something essential, what they call internal embodiment. In the paper, led by Akila Kadambi and colleagues, the team defines internal embodiment as a model's ability to persistently monitor its own internal states, things like uncertainty, processing load, or even a form of computational fatigue. The claim is that while modern multimodal LLMs can process text, images, and sometimes video, they lack any stable internal grounding analogous to a biological organism's awareness of its own body. The researchers demonstrate measurable failures tied to this gap. For example, they show that leading models misclassify point light displays of human motion, those sparse dot animations often used in cognitive science to test motion perception. Humans can reliably infer complex actions from these minimal cues. Current models, according to the paper, struggle in systematic ways. The argument is that without a bodily anchor, these systems lack the structural priors that make human perception and reasoning robust. To address this, the UCLA Health team proposes a dual embodiment framework. This would combine external embodiment, sensory interaction with the world, with internal embodiment, meaning persistent tracking and regulation of internal computational states. They also call for new benchmarks specifically designed to test internal state awareness and consistency over time. For practitioners focused on model safety and alignment, this is a big deal. Rather than just scaling parameters or adding modalities, this research suggests we may need architectural innovations that embed self-monitoring directly into the model loop. Published in Neuron, the work carries weight, and it challenges a core assumption that more data and more scale alone will produce robust intelligence. Next, we turn to a major policy and infrastructure story with significant implications for government AI deployments. ProPublica reports that in late 2024, the Federal Risk and Authorization Management Program, better known as FedRAMP, authorized Microsoft's Government Community Cloud High, or GCC High, despite persistent gaps in encryption documentation and security evidence. According to internal memos cited in the report, FedRAMP reviewers had flagged missing diagrams and unresolved doubts about encryption controls dating back to 2020. Yet the authorization proceeded. One key factor: GCC High was already widely deployed across federal agencies and the defense sector. In other words, the system was too embedded to easily halt. The report highlights structural issues inside FedRAMP itself, including understaffing and an annual budget of roughly $10 million. Reviewers were reportedly under pressure to approve a platform that agencies were already relying on, even though some technical assurances remained incomplete. For technical leaders in regulated industries, this raises uncomfortable questions. If GCC High, positioned as a high-security cloud environment for sensitive government workloads, was authorized without fully verified encryption documentation, what does that mean for assurance processes more broadly? As AI workloads increasingly move into government and defense contexts, cloud security validation becomes foundational. This story underscores the tension between operational urgency and rigorous verification. Now to infrastructure on an entirely different scale. SpaceX has filed for an initial public offering, with Elon Musk stating that proceeds, reportedly up to $75 billion, will fund a plan to launch as many as 1 million data center satellites into orbit to support AI workloads. The proposal envisions orbital data centers designed to process AI tasks in space. Industry observers have compared the concept to Microsoft's Project Natick, the undersea data center experiment that ultimately faced economic and operational hurdles. Experts cited by Reuters and others warn that orbital modules would face severe constraints: cooling in a vacuum environment, radiation exposure, high launch costs, non-upgradability of sealed units, and ongoing delays in SpaceX's Starship program. Even if technically feasible, the economics are daunting. Ground-based data centers benefit from continuous hardware refresh cycles, established power infrastructure, and far lower deployment costs per compute unit. Orbital infrastructure, by contrast, would require extreme reliability up front, since upgrades or repairs would be impractical. Still, the fact that SpaceX is explicitly tying its IPO to AI infrastructure signals how central compute has become to corporate strategy. Whether or not orbital data centers become viable, this move reinforces a broader trend. AI is reshaping capital markets and long-term infrastructure bets at planetary scale. Our fourth top story stays in the research domain but focuses on efficiency rather than embodiment. A new Arxiv paper by Jiashu He and colleagues introduces an entropy-guided decoding framework for large language models. Titled, Think Twice Before You Write, an entropy-based decoding strategy to enhance LLM reasoning. The core idea is to adaptively branch on high-uncertainty tokens during generation. Instead of committing to a single linear chain of thought, the model maintains a dynamic pool of partial rollouts, concentrating compute where uncertainty is highest. The authors also propose a rollout-level stopping criterion called entropy after think, or EAT. On benchmarks including GSM 8K and AMC 2023, as well as perturbed variants, the method reportedly improves reasoning accuracy. Most strikingly, the paper claims that smaller LLMs using entropy-guided decoding can achieve performance comparable to GPT-5 level systems at a fraction of the computational cost. If these results hold up under broader replication, this could materially change how we think about scaling. Rather than relying solely on larger base models, smarter decoding strategies, specifically uncertainty-aware branching, could unlock substantial efficiency gains. For teams optimizing inference budgets, entropy-guided decoding may be a concept to watch closely. Now, for a few other key updates in our lightning round. Another Arxiv preprint titled Empirical Validation of the Classification-Verification Dichotomy for AI Safety Gates evaluates 18 classifier configurations and 3 safe reinforcement learning baselines on MuJoCo benchmarks. The authors report that classifier-based safety gates systematically fail to oversee self-improving AI controllers across hundreds of iterations, even under idealized assumptions. In contrast, they introduce a Lipschitz ball verifier with ball chaining that achieves 0 false accepts and provable safe traversal in high-dimensional parameter spaces. For researchers working on scalable oversight, this challenges the prevailing reliance on classifiers as safety filters. In conversational AI, a separate preprint titled Criterion Validity of LLM as Judge for Business Outcomes in Conversational Commerce tests a 7-dimension rubric against real conversion outcomes on a major Chinese matchmaking platform. The study finds that need elicitation and pacing strategy correlate significantly with conversions, with a Spearman row of approximately 0.36, while contextual memory does not. Equal-weighted composite scores underperform, and the authors recommend conversion-informed reweighting and a 3-layer evaluation architecture. For teams using LLM as judge frameworks, this is a reminder to validate metrics against real business outcomes. On the product front, Prompt2CAD has launched a platform that converts plain language furniture descriptions into parametric 3D models. The system uses Claude AI for language rendering and Three.js for real-time rendering, and it can export CAD native formats including STEP and DXF, as well as STL and OBJ for 3D printing. With pay-as-you-go pricing starting at $5 and $2 in free sign-up credit, Prompt2CAD is targeting interior designers, woodworkers, and architects who need rapid, manufacturing-ready prototypes. In healthcare, a multi-site study published in JAMA tracked AI-enabled ambient documentation tools, commonly known as AI scribes, across 5 U.S. hospitals. Comparing 1,800 clinicians using scribes with 6,770 controls over 2 years, researchers found daily reductions of 13 minutes in EHR time and 16 minutes in documentation, along with modest productivity gains of 0.5 additional patient visits per week and approximately $167 in monthly revenue per clinician. The gains were larger when scribes were used in more than half of visits, suggesting adoption intensity matters. Finally, Wall Street is scaling up to finance the AI infrastructure boom. Goldman Sachs, Morgan Stanley, JP Morgan, and Citigroup are building integrated teams across lending, markets, and private capital to fund data center projects now reaching into the tens of billions. Citigroup estimates that up to $3 trillion in capital could be required by 2030 to support AI data center buildouts. That means bankers increasingly need expertise not just in finance, but in construction risk, power provisioning, permitting, and specialized equipment supply chains. And that's your AI briefing for today. The landscape is moving faster than ever, and we'll be here to track it with you. For more insights, visit us at letsdatascience.com. Thanks for tuning in, stay curious, and we'll be back tomorrow with the latest in AI.